Hello and welcome to Unit 8, Part 3. My name is Mr. Bell and today we're going to talk about equivalent functions. Equivalent functions are equal in value and should produce equivalent graphs and equivalent tables. Now, the main idea of equivalent functions is that functions can be written in different forms. Sometimes you simplify, you combine like terms, you rearrange parts of the equation, but in the different forms that they produce the same results. They'll produce the same graph, they'll produce the same table of values. A good example of that is if we take a quadratic and we factor it. Once your answer is in factored form, it is the same function as the original question, it's just in a different form. Let's see if we can apply that to a few examples. In this first example, it says which expressions are equivalent to 9x squared minus 25. Select all that apply. So what I'm doing now is I'm looking at the components and the parts of this function in the question and seeing how I can rewrite it into different forms. Well, I'm going to do that over here in blue. I know that 9x squared minus 25, that's a difference of two squares. And you may remember from the factoring chapter that actually factors into 3x times 3x would give me the 9x squared, and then the negative 5 and the positive 5 would give me the negative 25, and my outer and my inner would cancel. So the factored form of this function is letter A. Let's see what else we can get from this. I also recognize that if this is the difference of two squares, then it can be written like this. The square root of 9x squared is 3x squared, and it's the difference of 5 squared. These two functions have the same value, the same meaning, the same graph, the same table of values if you were to plot them on the table. So they are equivalent functions just written in different forms. Now, answer choice C would not give me that as the result. If I quickly did 3x minus 5 squared and multiplied that out very quickly, I would get 9x squared minus 15x plus 25. Combining the like terms, 9x squared minus 30x plus 25. That is not my original function, so I know answer choice C is not equivalent. And answer choice D looks like they tried to factor out a 9, which could work, except if you can't factor out a 9 from 25 without leaving it as a fraction, and they did not do that in the answer choice there. So the two equivalent functions are A and B. On this slide, we're also asked which expressions below are equivalent. And equivalent just means, well, they're equal in value, they have the same graph, they have the same table, they're just written in different forms. And we can do most of this by factoring, but towards the end of the video, I'll show you what it actually looks like to graph this on a calculator and what the table looks like, which is just a different way to solve this kind of problem. So if I take a look at this x minus 4, x plus 4 factors, I'm trying to find which of these at the top are equivalent to that. And I know that x minus 4 and x plus 4 are the factors of a difference of two square quadratic, which means its equivalent function would be this one. All right, moving on to the next example there. X squared minus 4x minus 12. I would be looking for what multiplies to be negative 12, but adds to be a negative 4. It's definitely some combination of 6 and 2, and to get a negative 4, the 6 would get the negative. So my factors would be x minus 6 and x plus 2, which matches the first function up here at the top. Those are equivalent in value. One's just in factored form and one is in standard or the quadratic form. And the last example there at the bottom, x minus 10 times x plus 1. We could either go up and factor our last choice to see if that worked, or we could just multiply or distribute on this example. So distributing this x to both, I would get x squared plus 1x, and then distributing this negative 10 to both, I would get negative 10x minus 10. And combine my two like terms in the middle, I get x squared minus 9x minus 10, which, if you notice, matches that middle function there. We just identified which of these expressions are equivalent, just in different form. I would have liked to have shown you this example actually on a calculator, but I was having some technical difficulties. So let me try to explain a different way to do this if factoring isn't your strong suit. I took this particular function, x minus 4 times x plus 4, and I put it in my calculator under the table function. So I went to menu and my table, and this was in my y1 position. Since I'm trying to find which of these other three functions are equivalent to it, I continued under the y2 part to put this function, y3 to put this function, and y4 to put this function. Here are the results in the calculator. It gives me a list of x values and then the particular y values for the actual question 1 or function 1, the y values for function 2, y values for function 3, and y values for function 4. Well, if I'm looking for which equations or functions are equivalent, I'm looking for which ones produce the same table, meaning this particular function and this particular function, if you notice, they have the exact same values for y. When x is negative 10, the y1 has a y value of 84, and so does the fourth function. The first function has a y value of 65, so does the fourth function. So that tells me, back from our original listing of the four, that my first function is equivalent to my fourth function, and that would allow me to make that same choice we did by factoring. So I know that's kind of cumbersome. It would have been nicer to see it on the calculator, but whatever kind of calculator you have, type in all your functions into the table, and you're looking for which columns or which tables have the exact same values, and those particular functions are the ones that are equivalent, just in different form. All right, hope this helps, and thanks for watching.